Hey, hi everyone. Spotlight, portrait mode, something now. I don't know what it is. Mm, okay, let's continue. This is day 31, and let's continue our study. We have till now covered um, AI, the path towards generative AI. We have covered. We started with understanding of AI, then machine learning, and then we've got into models like what are classification models, regression models, linear regression, logistic regression. You've looked at decision trees, random forests, naive Bayes, clustering algorithms, which are unsupervised, k-means clustering, and what else did we look at? Because we need to program all those later on. One by one, we need to program each of them, which we've been pushing, but yeah, the focus should be there because programming them hands-on with some sample data will be giving much more better understanding of how things work and how we can apply them to the specific use cases. So, uh, thinking like if you take one regression problem, we can actually try it out with multiple approaches that are there, like linear regression, decision trees, naive Bayes. Naive Bayes is for classification. So, uh, um, neural networks and all that could be. We could look at all of them and see how they are working and stuff random for us. And we can also apply different optimizers with respect to gradient descent and ARDA and all that stuff. And we can also am I missing any algorithms other than what I have said just now? I think we covered all of them. Of them that we have covered, there are multiple out there, but we have covered whatever is relevant to us. Now coming to neural deep learning, we started with AN and artificial neural networks, and then we came to CNN. We then came to RNN. We looked at um, forward propagation, back propagation, and then we looked at um, how to address the overfitting problem by dropping cells and dropping cells, reducing layers, and uh, I'm not able to recollect different techniques into address overfitting, but primarily the major one is where we actually drop certain um, cells within the layer so that it doesn't remember everything and it doesn't get to overfitting stage. And uh, coming to CNN, I think the focus is on image, on how we read the image, and the image being big, how do we scale it down? So it has a frame model where it keeps moving that particular frame or filter, or we call it filter or kernel, and that filter kernel will come with certain weights attached to that particular kernel, and we move that filter or kernel across the image, and that movement steps is called strides. So the strides can be defined as one step or two steps kind of stuff. In order to have equal consideration of the edges and the center images and all that stuff, we add some padding to the image so that it's a dummy padding of zeros around the image so that we cover the edges also in equal um, filters or kernels compared to the center ones. Um, Basing on different kernels, after training, it will start extracting different features within this particular um, image, and mm, These kernel outputs are in turn again converted into a single input, um, and that input is given to a normal ANN, and the ANN tries to predict basing on those inputs. It tries to predict what is the output value, and the output value can be used for classification or any purposes for requirement kind of stuff. We can revisit CNN, but this is the outlier idea of CNN. Coming to RNN is where the which is what we use majorly for our NLP. Hey, by the way, I got a gift from my daughter. She gave me an Iron Man. So what I'm gonna do is like keep this Iron Man every day beside study time, so that it is motivation. That's a different story, and we'll discuss about it sometime later when we really have time. Okay, coming to RNN, recurrent neural networks. I think the challenge with neural networks is that when it deals with the problem where it needs to consider sequence of inputs where each input is not independent of each other, there is an interdependency between each input kind of stuff. So and the output is dependent on the sequence, not just the inputs in that particular order, like ABC to BCA to CAB. Kind of it has dependency on each of the letters coming in different sequence kind of. So that kind of a time series data or sentence with list of words or a word with list of characters, anything like that would be considered as an optimal use case for RNNs. So RNNs come with the concept of recursion where the uh, the output of the RNN is given in turn as input to this particular RNN itself. So the usual pattern is we have W1x1 plus B, like Wx plus B, y is equal to Wx plus B. But what happens is here when we apply recursion, the output of the previous will become the input of the, so it will become Wx plus UH, where H is or you can say Uy t minus 1, like the previous input, plus B. So that's how the equation will be. So the previous input will also be considered as part of the, so x1 becomes x1 plus x1 comma y0, then x2 comma y1, x3 comma, like that it will consider uh, the outputs of the previous value. So it's not just an output of each input and then combining them together or processing them separately, but it is always uh, input of output of x1, x1 plus x2, x1 plus x2 plus x3 output, x2, x1 plus x2, x3, x4 output. So it goes in all in a series, but a combination of it with the kind of a context of what is there previous to xn. If it's xn, it considers the context of x1 to xn minus 1, and then on top of it, xn use corresponding output. So like if there is a list of words that are there and then these are xn minus 1 words, then xn word is predicted based on xn minus 1 words that is there kind of stuff. So that's the interesting part of RNN. So the output, as you can see, the output is could be to find out the next word, and let's say the word is represented by some vector. Then it's a sequence of letters, like n minus one is the input, and xn word is the output, right? A word or a letter is the output. So that is the sequence to vector output. So there are different combinations that we can see. It is sequence to vector, sequence to sequence. That is, for example, translation. If we have a list of words and in English, and then we want it list of the words converted into French or Italian or whatever, then it would take each word and then it would convert the equivalent one basing on the context. It's not just the word becomes this X. It's not word by word conversion, but based on the context, it would do a translation to a sentence, meaningful sentence of the specific language. So that is sequence to sequence, and then there could also be chance of sequence to vector, where, for example, there is a sequence of words like a movie review, and then we want to predict saying whether it's a um, good review, bad review, or we can actually say sentiment analysis, saying is it what kind of a sentiment does it reflect? uh, is it like somebody is scared, or like that kind of. So a sequence of words to vector is also possible. So sequence to vector, sequence to sequence, and then a vector to sequence is like more like embedding, right? Like maybe you give a number, and basing on the number it actually says what is the word related to that particular number, kind of stuff. So uh, a word or a list of characters or whatever. So it's vector is what you give as input, and that gives you a sequence output. So something like that could also be possible. Um, but there's a challenge here, that is diminishing gradient or exploding gradient kind of stuff. So what happens is the weights are same. The one key thing is x1 weights and the previous output input, like y t minus 1 weights, let's say u, are same across these recursion sequences, even though it goes x1 x2 x1. So what happens is when you multiply, when you say u y1, u yt minus 1, yt minus 1 is again w x0 or xn minus 1 plus um, u y t minus 2. Correct. So then what happens? U into u, multiplication will happen because you are multiplying again with u. So it depends on the u, saying if the u is number like let's say 10, then if there are 100 words, then 10 power 100 is the multiple, then it becomes too big, right? So uh, yeah, or let's say if it is u is 0.1, then 0.1 into 100 will become very small, right? So it'll make it too small that the influence of that particular output or input, both of them, will be very small. So uh, both ways, it's a problem to handle. So and what happens is it loses the context after, means a word that has come 10 steps before, um, either will influence the overall output to a major extent, or it will diminish to an extent that we don't even know that there's a word called um, some word x in the particular 10th place is gone, because the weights are, it is multiplied with 0.0.1 whole power 10, and the impact of it on the output is minimal, right? So this is the problem with the base RNN. So that is the reason base RNNs are not used extensively. Then they introduced, to solve this problem, they introduced LSTM and GRU. So long short-term memory, LSTM, and then GRU is a gated recurrent network. Um, um, how does these work is they'll start two parallel paths. One path will remember the one path will carry the chain of output that is coming in from each of them. One path will remember the one path will remember the output separately without being multiplied by the weights. So because multiplying by the weights is where it is being impacted, right? The diminishing or increasing or whatever. So the diminishing or increasing will still be there, but it will be there with the baseline path, and on top of it they're also carrying the actual output of the previous separately without multiplying with any weight. So it is not influenced by weights. That's the logic in LSTM. It's not a big deal, but it's a good logic on how they have done. They've used a sequence of layers to in order to consider, and it also has actually they use sigmoid function to decide on how much they want to remember. So it's not like we always remember all the words kind of stuff, but um, the network on its own takes a call how much it should remember the previous output. Kind of. For example, a sentence that is there, the sentence is already completed. So do we need to necessarily remember everything? Do we need not necessarily remember anything? That how much percentage of the previous context should we remember is also learned by network on its own. So let's say what happens if I remember 50%? What happens if I remember 60%? What happens if I remember only 20%? So that it will try to adjust as if we adjust weights in a AI or a machine learning network. They adjust that percentages as well, and then that percentages have create certain kind of impact, and basing on that impact they pick up the percentages at each level. And so that's how this sigmoid that's how this LSTMs and stuff will work, by deciding on what amount of influence should it consider for the next level, so that we are not trying to combine all of the inputs from the previous. Instead, it will have some weightage of the previous, and then also some weightage of the current data that is there at that particular step. They're called steps, like each of the words or whatever input is called steps. Okay, till here we are clear. Only thing we have also looked at an example where it was actually predicting the next number, like and how this math works, math multiplication works, and all that, that we have seen. Observe tannage functions, how does it work, sigmoids, how does it work, and all that we have looked at it and stuff. But what we didn't look at is are still the open, when in a sequence to sequence question that I've raised is sequence to sequence predictions. If I have what is my name, then the prediction, the answer is like, let's say your name is Raja, then how does it know when it is predicting that the first word should be your? Because what doesn't mean anything, what alone doesn't mean anything, what could have a number of possibilities after, like what is the meaning, what is your name, what is the place we are trying to go. There could be a number of things. The answer definitely varies basing on what kind of a question that you have, depending on the remaining words that are there. So before looking at the remaining words, how does sequence to sequence predict the next word, or does it go back and correct the words? How does it work? So sequence to sequence is something still an open and question. So we need to study it and understand it better. So that's still kind of open. So that is where we are. So we need to go deep into it. We need to study transform. Okay, so let's look at. We looked at. Okay, let's share the screen. Okay, entire screen, and then share different types of RNN. Gated recurrent unit, LSTM, and another machine that has been vanilla RNN is something, yeah, bidirectional and deep and LSTM GRU. And then after that, 1 to 1, 1 to many, many to 1. Sequence of output. Expanding gradient, vanishing gradient. So sequence to sequence models are so let it be on more on and the video today and will focus on this video will focus more on revision kind of stuff but I'll keep the exploration open on to understand more on the sequence to sequence kind of stuff factors with respect to LSTM or GRU or whatever and then we will also list out the next steps on what all needs to be covered for us to go towards the overall generative AI concepts, including NLP. Um, from here, we should have the pathway. Should cover those and understand those. We should also focus on doing a practical programming session kind of stuff to understand how this really work programmatically as well. So we know what are the gaps when you go for programming implementation as well and how things behave when you change things. Okay, that's it, guys. Then thanks. We'll again meet again tomorrow.